2.2 is exponential functions. It's going to take us 2 days to get all the way through this. We'll do objectives A and B today and maybe start C. You will need graph paper, so I'm going to pass that out. Another thing I'll note is the MML is tomorrow. Mrs. Gordon's going to check in there, and then she can send you elsewhere if there's a place free to go. MML is tomorrow. Okay, so here's the formula for an exponential function. So b to the x is like the parent function, and then this is the shifted form here, the a times b to the x minus h plus k. So this is like the parent, and then this is the transformed So what makes an exponential function is that x, your variable x, is the exponent. So x is the exponent. So what you have for b, that's the base of your exponent. That's part of the parent function. The a out front is like your vertical stretch or shrink. It also would tell you about your reflections over the x. This minus h on the inside, that's your horizontal translation, your horizontal shift. And because it's parentheses and has the minus sign, it's opposite. So just like normal with any function, if it's inside with x, you're moving left and right, and it's the opposite. And then the plus k at the end, just like always, that tells you your vertical shift, so what you move up or down. Okay. So this is left, right, and this is up or down. You can use your calculator to evaluate these. If you don't have a calculator right now, you can do these on your phone. So it'll be okay to use your phone to evaluate these. When it comes to quiz or test time, I will have calculators for you. So on your quiz and test for this chapter, there will be a calculator and no calculator part. Obviously, if it says use your calculator to evaluate, that would be on the calculator part. Okay? Round to the nearest thousandth. So pay attention to how you're supposed to round. Thousandths, that would be your third decimal place. So you're plugging in 0 for m. So W of 0 So I would do, if you're using your phone, I would do the exponent part first, so order of operations. So you would type in the base, like 0.8, hit your little X to the Y button, type in the 0, hit equals, and then multiply by 330. So this one does give you an exact answer, so you don't need to round it. You should get still 3,300. Okay, you plug in 5, you do need to round. So 1081 and then 0.344. And now 7.2. This was, I got 661.853. You guys able to get those values? Alright, let's look at the next set of questions here. Now we're looking for exact answers. So no rounding. Use fractions. Okay, use fractions. There's not this exact type of question on the no calculator part, but the work that we have to do, you should be able to do without a calculator. You might use it for another type of problem. So you should be able to do these without a calculator. Okay, so f of -1. Use your order of operations. So first, you want to take care of simplifying your exponent. Okay, so -1 minus 1 is -2. You need to do exponents before multiplying. So 3 times, you need to do 2 to the -2nd power. Again, you should be able to do that without a calculator. So 2 to the -2, what is that as a fraction? 1/4. So the negative exponent makes this a fraction, and then it's 2 to the 1/2 squared, so 1/4. Okay, and then 3 times 1/4 is 3/4. Okay, f of 1. So simplify the exponent first. Okay, so 1 minus 1 is 0. And you have to do 2 to the 0 before multiplying. So anything to the 0 power is 1. So you get 3 times 1, which is 3. Okay, do the last one. So you get 3 times 2 squared, so 3 times 4, should have gotten 12. Okay. questions about that? So knowing how to evaluate these is going to be helpful. We're going to be graphing, so we'll be making tables for most of our graphs. So knowing how to evaluate them either with or without a calculator is helpful. All right, so objective B is graphing exponential functions. Okay, so this is a parent function. So not all parent functions your base is 4, but if it's just y equals some base to the x, that's a parent function. All right, and we're going to make a table. It says go from -3 to +3. We won't always have to do that many numbers. So we're plugging these in. Since you're graphing, if you want to use decimals, that's okay, but I'm going to write these as fractions just so you get used to the negative exponents and how to evaluate these. So 4 to the -3rd is 1 over 4 cubed, because the negative makes this a fraction. And that's 1 over 64. So what would 4 to the -2nd be? 1 over 16, good. And then 4 to the -1, 1/4. Okay, 4 to the 0 is 1. 4 to the 1st, 4 squared. And then 4 cubed is 64. Okay, so when I go to graph this, I'm not going to graph the 364 because it just really does not fit very well in my graph. This is 18. Okay, so I'm going to graph these points. So -3 and then 1 over 64 is really small. So I'm close to this x-axis. I'm going to try to get as close as I can here, because 1 over 16 is also really small. And so is 1/4. Okay, then I have 0, 1, 1/4, 2, 16, and then 3/64. So the more negative I get, the smaller that y value is. So the next one, so 4 to the 4th is 256. So 1 over 256 is really, really small. So you're getting closer and closer here to this 0, but you're not actually getting there. So I want to try to show that I'm not crossing or touching the x-axis, but it's kind of hard to draw that, so just be careful. If you accidentally touch the x, that's okay, but I shouldn't see your graph going through the x-axis. It doesn't go through the x-axis because your x-axis is a asymptote, and the reason for that is because your values of y get closer and closer to 0, but they don't actually ever get to 0. So there's a horizontal asymptote. And the equation of that is y equals 0. Because you're approaching 0, your y values are approaching 0, but they don't ever reach 0. So all exponential functions have horizontal asymptotes. Okay, clearly label the y-intercept. So here's my y-intercept. That's 0, 1. So all exponential parent functions will have a horizontal asymptote at y equals 0 and a y-intercept at 0, 1. So no matter what your base is, here my base is 4. If my base were 2 or 10 or 1/2, it's still going to have 0, 1 and a horizontal asymptote at y equals 0. Because when you plug in 0 for an exponent, it always gives you 1. It says clearly label one other point. We have several labeled graphed, so it doesn't matter. I'll just pick 1, 4. Okay, determine if it's increasing or decreasing. So if you read this from left to right, is the graph going up or down? Up. You can also look in your table. As x goes up, your y values go up. So it's increasing. Another word for that with exponential functions is growth. Exponential growth. Okay, let's look at our domain and range. Do you have a minimum x value? No, what about a maximum? No. Look at your function. You can plug in anything, negatives, positives, 0 for x. So all your x values are good. So exponential functions, your domain is all real numbers, negative infinity to positive infinity. All exponential functions are that way, unless there's something crazy thrown in that they're include a radical or they're in a denominator. That's not going to be happening. Or what could happen is like we have a real world example and they tell you you don't want negative x values, but it would say that at the beginning. So in general, all exponential functions have a domain of negative infinity to positive infinity. Okay, range. I do have a minimum y value. And we talked about it here with this asymptote, is that you get closer and closer to 0, but you never actually reach it. But that has to be my minimum. So instead of having a bracket, though, I have parentheses, because I never actually reach 0. But I get all the way up to it, and then positive infinity. So your horizontal asymptote corresponds to your range. time, my parent function is y equals 1/4 to the x. So I'm still going to plug in -3 to +3 in my table. Okay, so when you're plugging this in, and it's a fraction with a negative exponent. So it's already a fraction. The negative exponent then does the reciprocal, making this just 4/1, which is just 4. Okay? So if it's a fraction already, a fraction to a negative exponent, and you have the reciprocal, so it goes back to the whole number. So that is 64. Okay, -2 would be 16. -1 would be +4. Again, you still have 0, 1. Okay, 1/4. 1/16, 1/64. Alright, so I will graph all of these except the -3 and the -3, 64. So -2, 16. -1, 4, 0, 1. 1, 1/4, 2, 1/16, and 3, 1/64. So this time, my graph kind of looks like the opposite of what I just had. My asymptote did not change. My y-intercept did not change. My other points did change. Is this graph increasing or decreasing? Decreasing. So another word is decay, exponential decay. So again, it's an exponential function, so my domain is all real numbers. Okay, my range. So you're going bottom to top. So even though it looks different than the one above, my minimum is still at 0, and I still don't have a maximum, so positive number. So my domain and range did not change either. Your range is based off your horizontal asymptote. So your range isn't going to change unless that asymptote changes. Questions about that? Okay. We're going to look at some exponential functions that have transformations now. So your parent function depends on what your base is. So parent function is always y equals the base to x. So 3 is part of my parent function here. Okay. This minus 3 is not. It's just y equals b to the x. Okay, so this is what I'm going to graph. I'm going to make a table, and I'm not going to use as many points, but I do want at least one negative. So I'm going to do -1, 1, 0, 1, and 2. Again, I'm looking at the parent function here, not at the minus 3. So 3 to the negative first power is 1/3. 3 to the 0 is 1. 3 to the first is 3, and 3 squared is 9. So I'm going to graph these points. I'm not going to connect them. I'm just going to go ahead and graph them, though. Okay. -1, 1/3, 0, 1, 1, 3, and 2, 9. Okay. It's the parent function, so it has a horizontal asymptote at y equals 0. Okay. But if I look at my transform function, what's the transformation? What does this -3 do? So it's at the end, so it's down 3. So if you shift down 3, does that change your horizontal asymptote? Yes. So I move the asymptote first. So I'm shifting that down 3. So that becomes y equals -3. And then I take all my points and I shift those down 3. And that is my graph. So all reals for domain. My range changed because my asymptote changed. So instead of being 0 to positive infinity, it's -3 to positive infinity. That's my minimum value. Okay? I know you think you could probably just make a table based off this whole thing, and you can, but you want to know how to do it based on the parent function and transformations, because when we start doing logs, you're going to have to do it with the parent function first. All right, so again, my parent function is just y equals 3 to the x. So not with the -2. Okay, so I'm not going to make another table because it's the same values there. My asymptote is here. Oh, actually, I think that's... negative 1, 1/3, 0, 1, 1, 3, and 2, 9. Okay. All right, so what does this minus 2 on the inside do? Right. Good. Shift right 2. If you shift right 2, does that change your horizontal asymptote? No. Okay. So that does not change. But all the other points change, but you're going to just shift them right 2. Right, meaning right, not left. Sorry about that. Okay, go right 2. Okay. Labeling is a good idea, so when I'm grading your quiz or test, I'll be able to tell what your final answer is. Okay, so what's my domain? Okay, and what's my range? 0 to positive infinity. Yep. Good. Questions about either one of these? Okay. So got another one. I'm going to change this from a 3 though to a 2. Okay, so what's the parent function? What's the base? 2. So just 2 to the x. So it's the base to x, just x. So we fill out our table. 2 to the negative first is 1/2. 2 to the 0 is 1. 2 to the first is 2. 2 squared is 4. So again, I'm just putting in the points. I'm not going to connect these. So I have a horizontal asymptote here at y equals 0, negative 1, 1/2, 0, 1, 1, 2, and 2, 4. Just so I have some more points, because 2 to the x, it doesn't grow quite as fast. I'm going to go ahead and put one more just to make it look a little bit better. So 2 cubed is 8. So 3, 8. Okay, that's a little better. Alright, but when I have y equals 2 to the negative x minus 2. Okay, if there was a negative out front, that's a reflection over If it's a negative out front here, it's a reflection over x. If it's negative out front, you flex over x. That's what we have done mostly. But when it's a negative inside here with x, that's a reflection over y. Okay, and then the minus 2 at the end means you shift down. You have to go in that order. Okay, do the asymptote first. If you reflect this asymptote over y, does it change? No. What about if you shift it down to? Yes? Okay, good. So that moves that here. So the only thing that is going to change your asymptote is if you move up or down. Okay, now take all your points, reflect them over y, and then down 2. So I have to reflect over y, down 2. If you're on the y-axis, when you reflect, you stay on the y, then down 2. Here, reflect, down 2. Reflect, down 2. And this one, reflect, and down 2. My domain, it's all real numbers, so negative infinity to positive infinity. Okay, what about my range? Yep, negative 2 to positive infinity. Good. Questions about that? Okay, that's where we're going to stop. So we're going to stop today. We'll do objectives C and D tomorrow, so we'll talk about E, Euler's number, and then we'll start solving some exponential equations.